pitch, swing and a miss, struck him out. The Philadelphia Phillies are 2008 World Champions of Baseball.
Oh, not the World Series. Today we're just talking about what a series is, okay? And it follows sequences very nicely, right? All that a series is the sum of all the terms in a sequence. So back in the day, the last unit with sequences, I started the whole unit with an arithmetic sequence that was 3, 5, 7, 9, 11, and so on and so forth, okay? Common difference of 2 and a first term of 3, okay? The series that would correspond with this would simply be the sum of those terms. Instead of having a comma, if we just changed all of those to a plus sign, we'd have a series. Okay? This would represent the sum of the first five terms, rather, right? Well, we can go on forever. Okay? So one goal of this unit is to get you guys to understand how to find what's called a partial sum. Okay? If we kept going on forever, the sum would just approach infinity. Okay? There wouldn't be some set number if this series continued forever. But what if we wanted to find the sum of the first, say, 21 terms in the series? Okay? That's the one problem we'll start with. All right? So a partial sum is one that is the sum of a set number of terms in a sequence. Okay? So if we wanted to find the sum of the first 21 terms, first thing we'd probably want to do is figure out what is the 21st term in this series. Okay? So if we consider the corresponding sequence, the corresponding sequence would have a formula, if you recall from the last unit, T sub n equals T sub 1, 3, plus the common difference of 2 times n minus 1. Let's clean it up a little bit. That would be 2n minus 2 plus 3, 2n plus 1 is the formula for the corresponding sequence. So the 21st term, we would just plug in 21 for n, and we get that T sub 21 is 43. Okay? So if we want to find the sum of the first 21 terms in this series, I'm going to explain how to do that now. All right? So we now know the 21st term is 43. So let me kind of erase some of these. We can just put some ellipses in the middle. Oh, I'll leave the 9. Right? Dot, 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 dot. Let's see. How about now we'll just start with a 37, 39, 41, and 43 at the end. Okay? So I have 4 at the beginning and 4 at the end to show you guys something that happens in here. Okay? So it would take you a long time to add up all of the first 21 terms in this series to find the partial sum. Okay? So let me explain to you guys how to do this a much more efficient way. If you think about it, 3 plus 43, 46, is the same as 5 plus 41, 46. 7 plus 39, 46. 9 plus 37, 46. Okay? The sum of each of these, the first and the last, the next and the next to last, etc. Each of those is giving us a sum of 46. So, of course, that number is going to change based on your particular problem. But what we have here is we've got a bunch of 46s we're adding here. How many? Well, not 21. Okay, there are 21 terms in the series, turns out, but we don't have 21 46s being added. All right. What we really have is half of that. All right. So there's a formula because you have the first and the last 146 is made from those 2 terms. Okay, 146 is made from the next 2 terms. So we don't have 21 of the 46s. And this type of situation leads us to the formula, right? In this case, this is the notation, by the way, for a partial sum. The capital S stands for series or sum. The sum of the first 21 terms is going to be, well, the formula for this is, so let me just actually replace this with S sub n equals n times t sub 1 plus t sub n all over 2. Okay, this is the general formula, and I want to explain to you guys where this fits in from this business, all right? So t sub 1 plus t sub n, well, think about it. T sub n in this case, n is 21, so t sub 21 is 43. So t sub 1, which is 3, plus 43 is 46. So here's your 46 in here, times n, times the number of terms you have, 21. So 46 times 21, but not quite. We've got to divide that by 2 because for every 2 of these terms, we get that 46. Okay? So this comes from, this means we multiply the number of terms in our partial sum, in this case 21, by the sum of the first and the last term in our partial sum. In this case, it was 3 and 43. And then we divide that total by 2. All right? So in this case, capital S sub 21 equals 21 times 3 plus 43 divided by 2. Now you could get away with not even understanding what I did here and just knowing the formula. That's okay. I just wanted to explain to you guys where all this stuff comes from, right? You add the first and the last term, and because that sum repeats itself so much, we get this formula, all right? And now we can clean this up pretty easily. 21 times, what is this, 46 again. So 21 times 46 divided by 2. Let's try to do this in our heads. 46 over 2 is 23. 21 times 23, well, 20 times 23 is 460. So we have to add on another 23. 460 plus 23 is 483. So the sum of the first 21 terms is 483. Okay, that's how to handle a partial sum for an arithmetic series, right? This is arithmetic. All right? Now there's some new notation that comes along with this also, which I want to go through a little bit, all right? So let me erase this for now. Okay. Another way to write this partial sum, like if I wanted to give you a problem that said, okay, find the sum of the first, let me write this, find the sum of the first 21 terms in the series. And it would have been 3 plus 5 plus 7. I have to give you at least a few of these so you see the pattern, okay? Another way to write all this, there's some new notation, okay? And that is, well, you see some of it right here, capital S sub 21. That is some new notation, and that means this as well, all right? But another way to write this is to use what's called a sigma symbol. Your first exposure to Greek life, right? You're not in college yet, but Mr. Bomsey was, and I was in a fraternity called Sigma Alpha Epsilon, okay? So this symbol I saw a whole lot in college, but also being a math major, I knew that this symbol means the word sum, okay? The capital Greek letter sigma implies a sum of terms, right? And the notation we use a k equals 1, and then we write 21 up there. Okay, so this means we're going to find the sum, the sigma means sum, of the terms from the first term in the series to the 21st term in the series. From the first to the 21st term, all of those terms we're going to add up, and that will be our answer. Okay? And what goes next to the sigma is the formula that corresponds with this series. Or rather, with really its corresponding sequence. Okay? And we know that we just kind of figured this out. It was 2k plus 1. Okay? So another way to write capital S sub 21, just to review what we've done, okay? If you're asked to find the sum of the first 21 terms, and I might have asked you for the first 7 terms, the first 80 terms, or whatever, this is how you do it. It's called a partial sum, okay? The way you do this is, or the way you denote this, is a capital S sub the number of terms in the partial sum, so capital S sub 21 in this case, equals a sigma going from a k equals 1 to 21, all right? And then next to the sigma goes our formula, all right? And this just means we plug in 1 for k, find what that is. We plug in 2 for k, find what that is. We plug in 3 for k, and so on and so forth. And we eventually will plug in 21 for k and figure out what that is. And then we add up all those numbers. That would take a long time, okay? That's where this formula comes into play. So if you have this kind of problem, you see it's an arithmetic sequence. You just do 21 times, well, when you plug in for the first term, 2 times 1 is 2 plus 1 is 3. And then the 21st term you would plug in, you get 42 plus 1 is 43. And you divide that by 2. So these all mean the exact same thing. To find a partial sum, this is the notation, and this is the formula. Okay, that's for an arithmetic partial sum. That's just one example, okay?